Now that we have verified the regression analysis assumptions, now we are ready to test for the significance of the regression model, and that test is null hypothesis being the slope coefficient is equal to 0. That means there is no linear relationship, model is not valid, or beta sub 1 is not equal to 0, which says that the linear regression is valid and there is a linear relationship, either positive or negative. Now there are two ways in which we can test this in the case of simple regression, and there is a t-test and there is an f-test. So t-test is you take the slope coefficient that we have estimated minus beta sub 1 from the null hypothesis, which of course is 0, divided by the standard error of the slope coefficient. And here the degrees of freedom for t-stat is n minus 2. So what is S sub b sub 1? The standard error of the slope coefficient. Standard error of slope coefficient is given by this formula. You take S sub yx, that is the standard error of y given x, and that comes from our regression output, divided by the square root of SSX, sum of squares of x. So you find S sub b1, divide that into that, and then you get a t-stat. And then you have the degrees of freedom is n minus 2. With that you will establish your t-table value, and then you will complete the test. So here is an example in your PowerPoint file. Okay, b sub 1 minus beta sub 1 divided by S sub b sub 1. But let's look at a numerical example in Excel now. The test that we want to do is null hypothesis is beta sub 1 is 0. The alternative is beta sub 1 is not 0. Let's say alpha is 5%. So we have b sub 1. Okay, we have calculated that way at the top. B sub 1 is right there. Okay. Now standard error of y given x. For this we need to look at our, let's go back to the partially completed measures of variation that we did. We left the MS part blank. So here for SST we won't have anything. So let's leave that. Okay, so here if you take the sum of squares and divide by the degrees of freedom, okay, we get what is called mean square. So this is MSR equal to mean squares regression. Okay, and you do the same thing for SSE. Take the sum of squares and divide by the degrees of freedom, you get what is called MSE, mean squares error. Okay. Now the standard error of estimate S sub xy is the square root of MSE. That is the standard error of y given x. That's what we need here. So S sub y given x is standard error of y given x. It's that. Okay. Now we can find S sub yx from the data analysis regression output also. So here is the output. So here regression SSR, SSE, so residual is another name for error. So you need to remember that. So residual and error are one and the same thing. So this is our MSR, this is our MSE. You take a square root of that, and that's your standard error. So here is that standard error, S sub yx. So you can get the value of S sub yx from the data analysis regression results also. Okay, so now we have that. Now SSX is from the very first table that we set up. So here SSX is right here. So S sub B sub 1 is standard error y given x divided by the square root of SSX. Okay. So now T stat will be B sub 1 divided by the standard error of B sub 1, and the degrees of freedom is n minus 2, which is the same as the degrees of freedom for MSE, which again we have from two different places. Initially when we set up the measures of variation table, so we have SSE degrees of freedom right there, or we can get the same thing from the regression output also, where here is the degrees of freedom for error. Okay, so now we can get the T table value T dot INV dot 2T, 5% and degrees of freedom, and want the P value, you go T dot this dot 2T, and here you have to provide the absolute value of T stat and the degrees of freedom. So that will give you the P value. Now you can get all of this information from regression output also. So here from the data analysis regression output, here is your coefficient, and right next to it is the standard error. Right next to that is the T stat value, and then the P value. So all the information that we computed are available one after the other. So C130, then D1 S sub B sub 1, okay, is D130 right there, okay, and E130 is the T stat, and F130 is the P value, and the P value is F130, which is here. So there are a couple of different ways in which this can be done, either from the formulas themselves or from the regression output of the results, and you should be able to do both of them. So t-test using t-table value, so t-stat is greater than t-table value, so reject the null hypothesis. Okay, or p-value, again p-value is less than alpha, so reject. So this is the t-test.